This lesson is for Advanced Algebra 1-6 on solving equations. Students have done a lot with solving equations already in their Algebra 1 class, and now that they're in Advanced Algebra or Algebra 2, just want to point out a few things and remind students of a few things as we get into solving equations. Know that this year we are going to be focusing on lots of different types of equations that we're going to be solving, and the first type we're going to focus on is the linear. Linear equations form a straight line when graphed, and you can always tell because the word linear starts with the word line, L-I-N-E. All the variables in a linear equation are to the first degree only. So what that means is students will not see x squared, students will not see x to the third or fourth, and so on. So we're not going to be working with any types of powers. All linear equations should be considered functions, except vertical lines. We're going to work with a word problem to begin, because those tend to be the toughest for students to handle, is turning a word problem into equation and then solving it. One more thing I want to point out is in the homework for this lesson, some of the problems say to solve the equation on the calculator using the solve command. Students can do that to check their answer, but know that for the most part when you're asked to solve, you're going to have to do it by hand, and you will not be allowed to use a calculator on a test or a quiz. So rather than simply taking the easy route on those questions, make sure that you solve it by hand first, and then you can use the solve command to check your answer. Let's just read through the word problem and then we'll give it a try. A concert group plans to visit 3 cities on a tour. 1/3 of the total distance to be traveled by the group is from home to the first city. 1/5 of the total distance is from the first city to the second, and it is 273 miles from the second to the third. Write an equation for the total number of miles and solve. I always encourage students to read the question to themselves all the way through at least once, if not several times, and then typically to take it one sentence at a time and start to create an equation out of each sentence as they go. So right away it says they plan to visit 3 cities. And if we're talking about distance, we know that the distance between the 3 cities has to add up to the total. So right now I'm just kind of making a skeleton for myself, just kind of a visualization to help me organize my thoughts as I go. So statement number 1 or sentence number 1 is finished. The next sentence says 1/3 of the total distance to be traveled by the group is from home to first. So that first city that they go to is 1/3 of the total. So I know it's going to have 1/3, and then I got to figure out how to incorporate the total distance. The total distance is what I'm trying to find. So that means the total distance I don't know. So I'm going to call that D. And if I take 1/3 of the total distance, whenever you do 1/3 of something, you're multiplying it by 1/3 or dividing it by 3. So I'm going to say 1/3 times D here, and that's going to represent 1/3 of the total distance. Typically when you see something of something else, that means times. So that takes care of sentence number 2. Sentence number 3, 1/5 of the total distance is from the first to the second. So that's going to be 1/5 D. Whenever it's 1/5 of a total, of always means times. And then it tells us flat out that the distance from the second to the third is 273. So that's not a variable, that's just a flat out statement of fact. And that's basically everything we need now. I'm going to go ahead and get rid of my skeleton so that I can concentrate on just the solving now. And so one of the main goals is to keep organized and keep everything lined up. Right away, I'm going to let students know that yes, there are fractions there, and yes, they have to deal with them. One of the things that I would like you to start to try to do is try to handle fractions in a little bit different way from what you may have been used to in the past. A lot of times when you see fractions like that and you know that you have to add them together, a lot of times students think that it's important to do that common denominator and change the fractions so they can be combined. While that is true that they need to find a common denominator, they don't need to change each fraction. They can simply use that common denominator to eliminate the fractions. So what we're going to do is put parentheses around both sides of the equation. We technically don't need any parentheses on the right hand side, so we're not going to incorporate them there. If this was D with something else, then we would include parentheses. The common denominator here between 3 and 5, a number that they both go into, is 15. So I'm going to multiply both sides of my equation by 15. What that's going to do for us on this side is I'm going to distribute the 15 to everything on the inside of the parentheses. When I do 15 times 1 on top, I get 15, and then the 3 gets divided. It's not 15 times the top and 15 times the bottom, because that 15 is just 15 over 1. So the 15 and the 1 multiply together on the top, the 3 and the 1 multiply together on the bottom, 15 over 3 is 5. And then the D is still there. We do the same thing on the next one. 15 times 1 on the top is 15. 1 times 5 on the bottom is 5. 15 over 5 is 3D. Then I still need to multiply 15 times 273. Simply just grab my calculator there and multiply that out. 4095. Once I've distributed that 15 to all the different pieces there, the parentheses go away. Over here, I can leave it as D times 15, but 15D is typically how we write a number times a letter. So now I'm going to continue to solve, and some of the things that you want to keep in mind are, if you have any like terms where the letters are the same, you want to go ahead and add those together. Typically I do underline those so that I can visually see that those need to be combined. Clearly I'm adding those, so I'm going to say 8D. Now I'm going to go ahead and try to get the D's together. Typically you'll want to get the D's on one side of the equation before you start to do anything else. It really doesn't matter which side you bring the D's towards. You can either bring the 15s over or the 8s over. There is no right or wrong there. Typically what I have kids do is to bring over the ones that are lighter. The smaller numbers are usually easier to bring over. So the 8 and the D are going to travel together. They are being added currently, so we're going to take them away to get them to move to the other side. The 4095 drops straight down, and over here we're simply going to add the numbers together. The D's do not drop because we're simply doing 15 minus 8. Now to get rid of the 7, since it is right next to the D, we do the inverse operation. 7 times D, the inverse operation there would be to divide. Could also multiply by the reciprocal, which would be 1/7. Make sure when you're dividing, when you type it in, it's always top number divided by bottom. Once in a while I have a few kids who mix that up. So always do top divided by bottom when you type it in, and you get 585 here. Another thing that students sometimes like to do is go ahead and cross out there. If they eliminate that step and don't want to write that, that's perfectly fine. Here you also want to just stop for a moment and make sure that the answer that you got makes sense. We got a number of distance of 585. One of the legs of the trip was 273, so the fact that we got a number significantly higher than that, but not too high, is a meaningful number. We also have a word problem, so let's incorporate the label there of miles. The last thing students would want to do there is go ahead and actually check their work, especially if this were a test or a quiz. Plug in 585 back in your original formula here and see if the two sides are equal to each other. Let me go ahead and demonstrate the checking of the work just to ensure that students indeed know how to do that. So I've started a calculator page on my TI Nspire, and I'm going to say 1 divided by 3 times 585 plus 1 divided by 5 times 585 plus the 273, and I'm hoping that when I hit enter that I get the number 585, and I do, so I know that I got it right. It's always good to double check your answers. So if this were a test question, I'd feel fairly confident that I got that one correct. Some other questions that I want students to pay attention to or watch out for is when there's subtraction signs in front of the parentheses. Common mistake here for kids is to want to distribute the 3W to the inside of the parentheses, but that would be the case if it looked like this instead. In the purple example, you would distribute the 3W. In the one that we're going to do, we will not distribute the 3W. The students need to pay attention to what is directly next to the parentheses before they start to distribute. Here what we're going to do is distribute that negative sign only. The 3W is going to stay put for now. So when we distribute that negative, that turns the 4 into a negative, and the negative there make that become a positive 6W. Notice that the parentheses were dropped. Technically right now we would not be able to combine the like terms because they're separated by a subtraction sign, and we cannot rearrange things until it's turned into all addition. Only addition is commutative, allowing you to rearrange numbers. So I'm going to go ahead and change this to plus -4. Now that I have all addition, I can go ahead and add, I can rearrange the numbers and add the like terms together. So I'm going to kind of combine some steps here. I'm going to change the addition, I'm going to flip-flop those two numbers, and now I'm going to get 9w. 3 and the 6 make 9. I still have a -4 there. Now I'm going to anchor the w by just drawing a little arrow. This is just a technique that I have begun to use with students. It's not entirely necessary that students do it, but I found that it helps students anchor the letter and allows them to maneuver the numbers to the other side. When you get to this step here, you want to look at which thing is further away from the variable and move those things away first. So the 9 is right next to the w, so we're going to deal with him later. And let's go ahead and move the 4 over. It's adding a negative right now, so we're going to add the opposite. We're going to do that to both sides. We still have 9w. To get rid of a number next to a variable, you would do the inverse operation, which is simply to divide. When we do that, we get 13 for w. Again, if you have time, go ahead and plug in the 13 for w and see what you get. The last thing that I want to look at with students is the distributive property. The distributive property, again, allows you to eliminate parentheses and distribute what's on the outside by doing multiplication. Typically, students will use the arcs to help them visualize what gets multiplied by what. Common mistake here is for students to work with a problem like this and believe that they have to distribute the 0.1 to the 2 and to the x separately. I want students to make note here that they will not use the distributive property on this one, but they will on this one. So the one in the middle here is simply multiplication. It's basically the same as saying 0.1 times 2 times x. The parentheses there are simply grouping the 2 and the x together, but the 2 and the x are simply being multiplied together, just like the 0.1 is being multiplied by the 2x. So all of those get multiplied together, and there is no distributive property necessary. Because of the grouping symbol here, we do want to go ahead and get rid of those parentheses. So I'm going to draw the arcs there, and I'm going to start from left to right, and I'm just going to simply work my way through. The 0.05x there is going to stay. Multiplying by the 0.1 times 2x there gives me a 0.2x. Here when I distribute, 0.25 times 100 is just 25. I'm going to leave the sign of the subtraction there. 0.25 times 3 is going to be 0.75 with the x next to it. Notice that the parentheses drop. Again, right here I have a subtraction, so I'm going to change that to plus negative. Now I can do some rearranging of adding the like terms together. I've got 5 cents plus 20 cents is going to be 25 cents x minus 75 cents x. So that basically gives me negative 50 cents x, or negative 0.5x. Could also simply type those in on the calculator to verify that it is negative 0.5. The 25 drops down, and now I'm going to solve for x. The x is going to be anchored, and I need to move the 0.5 and the 25. The 25 right now is a positive number, so to get rid of it, I'm going to subtract. Common mistake there is for students to see the subtraction and think that they need to add 25 to both sides. Remember that the subtraction is actually going with the number to the right of it, so we need to subtract the 25 to get it to go away. The negative 0.5x drops down, and we have negative 5 here. To get rid of the negative 0.5 next to the x, just like we've been doing, we're going to divide by negative 0.5. Keep in mind here that you should be getting a positive answer. Negative divided by negative is positive, and so our answer there is 10. One more thing I want to point out from the homework with students, when you're working with a problem like in number 5, when you see variables on both sides of the equal sign, your job is to try to get the variables to the same side or on one side of the equation first and then solve for y. Sometimes you have to move the letters around before you can actually begin to solve. A reminder to students, don't forget to, on a later date, go ahead and write a summary of this lesson.